And the topic is Virginia's ospreys face an uncertain future. Really a devastating predicament they're facing right now. We are so grateful for our upcoming speaker. Next slide, please, Lauren. Again, the program's being recorded. Please put your questions in the question and answer box. And let's speak a little bit about our speaker, Dr. Brian Watts. I have a little blurb here to read, but it only scratches the surface of the magnitude of the input this amazing researcher has offered to the conservation community in the Northern Hemisphere and certainly the Mid-Atlantic. Dr. Brian Watts is the Mitchell A. Bird Professor of Conservation Biology and Director of the Center for Conservation Biology at William & Mary. The author of more than 600 publications on avian ecology and conservation, Brian has studied birds since early childhood. He's conducted more than 1,000 research projects focused on solving conservation problems throughout the Western Hemisphere, but primarily within the Mid-Atlantic region of North America. He has worked with Osprey in the Chesapeake Bay for more than 30 years. His research attempts to explore general ecological principles that have broad application. Brian, we're so delighted that you are gracing our evening with this important presentation. Thank you so much. The screen is yours, sir. Thank you.
How's that? Can you see?
Yep, looks good.
Are we good? Yeah. Well, thanks so much for having me. It's a thrill to be with you. Thanks for your interest in this topic. The Center for Conservation Biology is a research unit within William & Mary that focuses on birds. We work with many, many species, but Osprey we have a long history with. If you don't mind, I'll start with a little bit of context, and then we'll work our way to Osprey. This is a figure from the Pew Charitable Trust that shows the relationship there of the food chain, the marine food chain, and where forage fish fit in. You can see there that forage fish are a critical bridge between many of our consumer fish, many of that are commercially important to us and always have been, to the plankton, the vast energy reserves that are contained within the plankton. These are the energy changers. They take the plankton and make it available to higher trophic levels, and so they play a critical role. There are several dozen forage fish species throughout the world. They're not just fish, as you can see there. Some are crustacean, mollusks, etc. Most are fish. These forage fish have a number of characteristics that they share. They have high reproductive potential. They oftentimes occur in large schools. Because they feed on plankton, they can concentrate lipid within their tissues. And they're well known for boom and bust cycles. So their populations can go up and down dramatically through time. One of the famous ones that you may be familiar with is the Pacific sardine. Pacific sardine and the cannery on the West Coast was the topic of Cannery Row, Steinbeck's novel from the 1930s. At that time, Pacific sardine were the largest fisheries in the world. What you may not know is that that fishery collapsed about 10 years after the Great Depression, which was the setting for Steinbeck's novel, and they have never recovered from that collapse. And one of the lessons from that particular fishery and many dozens that have occurred throughout the world is that when the population or the stock is in a downslope, take your foot off the gas and let those populations recover. Otherwise, you can drive them into the ground and they may not ever recover. Fishery scientists began to warn against what's referred to as fishing down the food chain in the late 1940s. And the reason they did that was because many of the commercial species of interest are in the higher trophic levels. And what they were trying to point out is that if we continue to fish out the lower trophic levels were effectively pulling the rug out from under our own commercial interests. That was 80 years ago. We didn't listen to their advice then, and we're still not listening to their advice. What do we do with these forage fish? We catch these in large quantities and we boil off the oils. These are the omega-3 oils that you're familiar with. Once those lipids are boiled off, we dry out the proteins and we convert that into fish meal. Historically, we have used that fish meal as feed for livestock like pigs and chickens. And so those are the two general products from forage fish that we use. The forage fish industry has exploded throughout all of the world's oceans. And so now we are harvesting about 22 million metric tons annually, worth about $15 to $20 billion globally. Increasingly, we are shifting the use of fish meal from traditional livestock to aquaculture. And you may or may not know this, but about 2 years ago, for the first time, we were eating more farm-raised fish than wild-caught fish. That is a trend that will continue. And so much of the expansion of fish meal is really due to aquaculture now. And many of the commodities traders project that sometime in the mid 2030s, we will outstrip the global supply. And so at that point, regardless of what happens with the fisheries, we will have to look for other protein sources. In terms of the Chesapeake Bay, we have many bird species, also marine mammals and fish, but in terms of the birds, we have many bird species that depend on forage fish. In the middle there, that's a pelican nest just above Tangier with an adult menhaden in it. But eagles, gannets, great blue herons, royal terns, many species depend on forage fish within the Chesapeake Bay. Many fish also depend on them, and some marine mammals depend on them in the Chesapeake Bay. But osprey are increasingly over the past 30 years or so being considered as sentinels for marine ecosystem health. Initially, that was mostly focused on contaminant monitoring, but in more recent years, they have also been considered sentinels for fish stocks. Why osprey in our particular case? Osprey are fish obligates, so about 98% of their diet is fish. They are widespread. So unlike pelicans that we just saw, pelicans nest in 2 to 3 places concentrated within the Chesapeake Bay. Osprey are broadly distributed throughout the bay, so they give us a broader indication of dependency. Unlike the fish that also depend on menhaden, they are highly visible, so we can observe them and quantify what they're doing. And most importantly, we have many available metrics that we can quantify. So when this issue came back to us about 8 years ago, we began to get reports that osprey weren't doing well within the Chesapeake Bay. Immediately as researchers, we think about the things that could potentially change or impact the population. There are 2 of those demographic things. One is adult survival, the other is reproductive rate. When we think about prey, we think about the influence of prey on reproductive rate. And so that is the pathway, that I chose to look at several years ago. So this relationship between prey abundance and reproductive rate, we actually have several metrics that we can use to look at this relationship. And I'd like to highlight one of those, which is brood reduction. Brood reduction is very sensitive to prey availability, and so it's one that is particularly good to look at. And what do I mean by brood reduction? It happens that osprey have this behavioral mechanism that allows them to match the brood to the available fish coming in. Okay, and they do that through brood reduction. What does that look like? This is what I refer to as a symmetrical brood. These chicks here, you can see there's 3 of them there in the nest, are about 6 weeks old, and you can see they look like identical triplets. They're the same size, at the same developmental rate, uh, stage. And so this is what happens when there's enough food coming into the nest to feed all of them equally. So there's excess food available, so they all develop at the same rate. You can compare that to an asymmetrical brood. In this particular brood, you can see there's an alpha chick, the large one, in the foreground, a beta chick there in the background, and then a gamma chick, the small, what we might commonly refer to as a runt, there on the left. Asymmetrical broods indicate that the alpha chick is dominating the food, and then the beta chick gets what's left over from him, and then if there's enough left over after that, the gamma chick gets it. And so there's sequential feeding within this particular brood, and that's an indication of food stress. Okay. One of the interesting things with osprey is that if there's not enough food coming in, there's a dominance hierarchy formed within the brood. You can see that the chick there, these chicks are about 4 days old. So this develops very early on if there's not enough food coming into the nest. You can see the bird on the right there has a dominant posture, and the bird there on the left has what we refer to as a subordinate crouch. So it is cowering. This behavioral relationship within the brood will persist throughout development if there is not enough food coming in. And so that bird on the right there will be fed first until it's completely full and walks away. And if there's enough food left over, the bird on the left will be fed. And so it's that differential feeding and the dominance that leads to asymmetric broods and ultimately brood reduction. This is those same 2 chicks about 2.5 weeks later. You can see the bird on the left, which was the dominant bird. You can see its crop there, that dark area there is full. And if you look at its breast, you can see how healthy and wide it is. The subordinate chick over on the right, it has an empty crop, and you can see that it's emaciated. That chick would die the next week. And so that's what I mean by brood reduction. The subordinate chicks starve sequentially. If there's not enough food ultimately to provision the dominant chick, the nest will fail and the pair will produce nothing. So that's brood reduction. It allows the pair to match the brood to the available food coming in. If they were to feed all of the chicks equally and there's not enough food, they would all die. None would survive, right? So it's a adaptive strategy that osprey happen to have. It's common within a number of raptors. Something about the Chesapeake Bay that you may be familiar with, and that is that the Chesapeake Bay is a classic estuary. We have freshwater inputs at the headwaters. Here you can see the Susquehanna, the Potomac, the Rappahannock, and the James. They account for about 80% of the freshwater that comes into the main stem of the Chesapeake Bay. We have oceanic or saltwater inputs at the mouth. That saltwater comes in, goes up the eastern shore, and cycles around. The fresh and saltwater mix, and this creates different salinity zones within the bay. These salinity zones dictate where different fish are located throughout the bay. So, and that depends on their salinity tolerances, the same thing for plants, and so forth. So the salinity gradient that we have throughout the bay has a lot to do with the distribution of organisms across the bay. Well, if we look at the distribution of osprey during the DDT era, so the Chesapeake Bay osprey population declined by about 80 to 90% during DDT. This was true for populations throughout the world, and the population collapsed down to the main stem. You can see the distribution there between the 60s and 80s during the DDT low. The population declined because pairs were producing inviable eggs. The hatching rate was about 30 to 40%, so very low for Osprey. As DDT was outlawed in 1972, and as that began to wash out of the bay, we began to get a recovery in hatching rate, and productivity began to climb out of that low. And so once we get to the early 1980s, hatching rates were above 85%. They have stayed that way since that time. So today, our hatching rates are 80 to 90%. They hatch fine. They are viable eggs. There have been two complete surveys of the Chesapeake Bay, one that we did here from the center, and that was in 1995 and 1996. We surveyed by boat 900 tributaries of the bay and mapped all the Osprey pairs. That took 2 seasons to do. That's my wife Marion there on the James, and we went to many different Osprey nests. We mapped about 3,500 pair of Osprey in the mid-1990s. There was an earlier survey that was run by Chuck Henney in 1972 that he published in 74, and that was during the DDT low. And in that intervening period, we see that the population was recovering and doubled in size over that time period. We have had no updated systematic surveys of the bay, but we have done some subsampling, which leads me to project that the bay population reached a peak in recent years of somewhere in the 10 to 12,000 pair range. The Chesapeake Bay is the largest breeding population of Osprey in the world by far, and it has always been a very important population on a global scale. If we compare the mid-1990s, our survey to Chuck's survey, what you can see is that the population is beginning to radiate out the tributaries. I showed you a map of what it was like during the DDT lows. By the 1990s, we were getting quite a bit of colonization up the tributaries, and this is where the primary growth in the population was occurring. That's still true today. We continue to get population growth in the lower salinity reaches of the bay, not so much in the main stem. One of the interesting things that I became interested in the 2000s was the differences in ecology between the pairs that were in the low salinity parts of the bay and ones that were in the historic main stem. There had been quite a bit of work in the main stem in the saltier part of the bay, but no work in the lower salinity reaches because pairs had not been there for several decades. And so I had a graduate student, Andy Glass, that compared the ecology. This is a pair with a blue catfish on the upper James, just below Richmond. And what Andy showed was that the diet shifts. There actually were many different ecological differences across the bay, but this one shows diet. And what you can see in the lower salinity reaches is that they were primarily feeding on catfish and gizzard shad, whereas in the main stem of the bay, they were primarily feeding on menhaden and a couple of other species. There is some overlap, croaker, that you can see there, but there are quite differences in diet, and that has to do with the salinity tolerances of the different fishes in the bay. So they're using what's in those different salinity zones. Mobjack Bay is a subestuary in the lower Chesapeake, and I want to show you some data from Mobjack Bay that we have, historical data, and show you what's been happening over the past 30 to 40 years in Mobjack. This shows the productivity in Mobjack Bay since the DDT period up to present. And what you can see is that productivity climbed out of the DDT period, reached a high in the early 1980s, and since the 1980s has declined. In fact, if you compare the two, you can see that productivity is actually retraced down through the DDT era and now is much lower than it was during the DDT crisis. In fact, in 2023, we produced 3 young out of 81 pairs in Mobjack Bay. I didn't put the 2024 and 2025, but this year we produced 5 young from 83 pairs. So it has remained very low, alarmingly low in Mobjack Bay. We are lucky that we actually had 4 generations of graduate students that have done Osprey work in Mobjack Bay since the mid-1970s. 2 of those were Mitchell Bird students, Chris Stinson and Peter McLean, and then my students, Andy Glass and Michael Academia. This is Andy Glass here working with an Osprey. And so what I'm going to do now is to show you what's happened in the Mobjack Bay area across these 4 generations of graduate students. This shows nesting success. So this is a proportion of pairs that actually produced at least 1 young. You can see that's declined by 60% over this 45-year period. For those pairs that were successful, that is, they produced at least 1 young, we had a 40% decline in brood size. So the normal brood size during the 1980s was 2. Now the normal brood size is 1. Those 2 things together combine to give you the reproductive rate. That's the number of young produced per pair. And you can see that we crossed a very important milestone sometime during the 1990s, and that is that Mobjack Bay went from a demographic source, meaning that it was producing more young than are required to offset adult mortality, which is so that's required to maintain a stable population, that you produce enough young to offset mortality so that the population is stable. They were producing more than that during the 70s and 80s. Since the 1990s, we have gone below maintenance and we've become a demographic sink. Okay, that is the alarming part of what's happening with the demographics. During that same time, what you can see is that brood reduction has increased dramatically. So over 70% of the young that are lost due to starvation. So they are starving in the nest in Mobjack. That was unheard of in the 1970s. Okay. If we look at the provisioning rate, this is the rate at which the males are bringing fish into the brood. You can see that that has declined by 90% over that period. So they're bringing in fewer fish to the nests. That is why the young are starving. This compares the diet in Mobjack Bay from Peter McLean's time to Andy Glass's time. And what you can see is that menhaden accounted for over 70% of the diet in the 1980s, but less than 30% of the diet by the 2000s. And what Osprey have done is to try to broaden out the diet. You can see that they're adjusting and using other fish. The problem is that we have had a decline in provisioning by 90%, but when you compare the quality of the diet between the 1980s and the 2000s, it has declined by 50%. So if you take 100 grams of the diet in the 1980s and you compare it to 100 grams during the 2000s, the energy content of that diet has declined by 50%. So the rate at which fish come in has declined dramatically, but the quality of those fish coming in have also declined. This is the provisioning rate from the 1980s to present of just menhaden. Okay, so menhaden are the reason that the diet quality has declined, and also the primary reason that provisioning has declined. So in 2021, my graduate student, Michael Academia, and myself executed an experimental study. That is, we set up an experiment where we provided menhaden twice a week to broods in the experimental group, and then we had control nests where we didn't provide menhaden. We were able to experimentally push productivity back to 1980s levels by providing menhaden to nests. So they readily accept these and feed them to chicks. And we were able to push the productivity back by adding menhaden. So What's going on in the Bay? I've taken a familiar story for you, and that's Japan. Most of you are familiar with the fact that Japan's population is declining. Japan's population is declining because of demographic stress. You can see that up until 2008, they were producing in excess of children, enough children to offset adult mortality. But after 2008, you can see that the population began to decline. And the reason it's declining is they're not producing enough children. And so the population is declining through attrition. And you can see that that is accelerating. So Japan is in a death spiral, in terms of their population. That's what's happening with the Chesapeake Bay Osprey population. So they're not in demographic balance. They're like Japan in that they're not producing enough young to offset adult mortality, and they can't sustain the population that way. Okay. So after we published the retrospective 40-year comparison, and after we published the food addition one, we had a lot of blowback or complaints from the fishing industry and also from the fishery scientists suggesting that Mobjack Bay was just a one-off. It was an anomaly within the Chesapeake Bay. This wasn't happening throughout the Chesapeake Bay. And they also threw out a number of alternative explanations. It was due to eagles robbing osprey, it was due to disease, or it was due to contaminants, or it was due to something that was happening on the wintering grounds. We knew all these things weren't true. And so I delineated a study area that you can see here in red. Represents a 10 parts per thousand salinity contour. This is the area of high menhaden availability. This is the area that I have believed that osprey depend on menhaden. Don't just eat menhaden, but depend on menhaden. And I delineated 12 study areas within this area that had about 500 pairs in total. Here you can see the study areas. There are 10 within this 10 part per thousand salinity contour. And you can see that there are two areas out here on the upper tributaries, the light colored ones. Those are in the lower salinity reaches where osprey do not depend on menhaden. The reason for choosing those was because it's part of these sort of alternative explanations didn't have to do with menhaden. All of these birds migrate down to South America and winter in the same area. So if there are problems on the wintering grounds, we would expect that those problems would show up not just in the main stem, but also in the lower salinity reaches. In terms of eagles, if eagles are the problem, we would expect it to show up more in the lower salinity reaches. It turns out we happen to do the eagle work in the bay, and that eagle breeding density in the lower salinity reaches is 10 times higher than it is in the main stem. So if there's an eagle problem, it should show up there. Similar with contaminants, etc. And so I was trying to isolate the effect of menhaden on the potential productivity issues. There are 4 areas that you can see there that are striped, and these are areas that in a paper that's currently in review, I'm comparing between current and back to the 1980s. So you can see Mobjack, which I just showed you, but there are 3 other areas that I'm also going to compare. Here you can see the results of the 2024 surveys in terms of productivity. None of the study areas in the main stem of the bay broke even demographically. They didn't produce enough chicks to offset expected adult mortality. And those chicks were starving in the nest. You can see an example of that on the right there. Both of the areas in the lower salinity reaches far exceeded the productivity needed to break even. It was like 1.4. So very good productivity there, but not so much in the main stem. One of the other things that happened in 2024 that we hadn't expected is that the pairs in the main stem, almost 30% of them never laid eggs. This is a female on the lower York River here. This bird came in late February at the normal time. We checked on this female throughout the spring. This is the way she was throughout the spring, sitting on the edge of the nest. She never laid eggs. We have never documented that in the Chesapeake, and it hasn't been documented, as far as I know, anywhere in the world. And so 27% of the pairs didn't lay. If you compare that to the low salinity areas, it was less than 4%. And if you compare back to what the historic rates were, they typically were less than 2% of pairs that didn't lay historically. And so we believe that this is also related to food stress, that the females do not have enough food to bring themselves into laying condition. This is a comparison of those 4 areas that from the 1980s to present. And what you can see is similar to what I showed you in Mob Jack Bay. There's the Mob Jack Bay, that reproductive rates in these areas along the main stem historically were up in the 1.4 to 1.5, well in excess of what's needed to break even. But now all of them have declined. If you look at brood reduction has increased in all of these areas. It's in the neighborhood of 1.3 chicks per pair. Compared to historically, it was down in the 0.2 to 0.3 range for most areas in the bay. So I think that over the past few years, from 2021 through 2024, we did quite a bit of field work. I feel like we successfully showed that Osprey were struggling in the main stem. And the question that kept coming back to us was, what are the implications for the broader Chesapeake Bay population? What are we going to see happen? And so that's really a meta-population question. And it boils down to, is there enough excess in the lower salinity reaches to offset the deficit in the main stem that we're seeing? You know, if we had birds dispersing from the low salinity areas to the main stem, would it offset, you know, the productivity deficit? And so in 2025, this past year, we worked in 23 study areas, including over 1,000 pair. And here you can see that we worked across the entire salinity gradient rather than just on the 10 parts per thousand in the low salinity areas. We had intermediate salinity areas. And surprisingly, at least to me, you can see that the deficit actually extended down to 5 parts per thousand salinity. None of the areas outside of the low salinity sites that you can see in blue there on the map broke even. All of those areas in low salinity areas broke even. None of the ones outside of that did. That was fairly frightening in terms of how large the deficit is. And so to circle back to the metapopulation question, the problem is that when you look at the deficit compared to the surplus, it suggests that we would need 1.8 pairs in the surplus in order to offset every pair in the deficit. Unfortunately, the reverse is true. We have 7.5 pairs in the deficit for every pair in the surplus. What that means is there's no way that the surplus part of the population can rescue or offset the deficit. The implication of that is that we absolutely, if we can't turn this around, that the broader bay-wide population will absolutely decline. And it has likely been declining for a decade or more. So, you know, in a fairly short period of time, so we're researchers, and our main focus, you know, as these problems come up, is that we want to take the box of uncertainty and we want to reduce that, okay? So industry came up with a number of alternatives, and we have systematically tried to resolve those. And so in a fairly short period of time, we have reduced the size of the box of uncertainty down to relatively few questions. So fewer and fewer over the last couple of years. And so, you know, I think there's general agreement at this point that there's not enough menhaden in the Chesapeake Bay. Even the fisheries scientists have come around to that understanding through the work that we have done to support a stable osprey population. Okay. I'm coming back to our chart here now. And so I feel like, yes, we have a reduced reproductive rate. yes, there are population level implications of that reduction. And yes, the reproductive rate declines that we have seen are related to prey availability. The real question, though, really gets to another level, and that is why. So there's not enough menhaden to support the osprey population. Next question is why, which is really a fisheries question. Do we not have enough menhaden now compared to historic levels because of climate? Maybe the climate change. Is it due to harvest, which a lot of the public feels that it's due to harvest? Is it due to water quality? So there are a number of possible explanations as to why there are not currently enough menhaden, and those remain open questions. As I've said from the beginning, I'm a bird head rather than a fish head, and these are questions that are more oriented towards the fish heads in the community, and so they're questions that we're urging them to address. As I think many of you may know, menhaden have truly become a political juggernaut. Many of the decisions that are being made with regard to menhaden harvest and industry really don't have much to do with facts or science. These are political decisions that are being made. And the public has come out and I think is increasingly making, their opinions heard, which is how we change politics. But it has been a fairly difficult political um, exchange over the past few years, and it continues to be. There's a lot of interests here in terms of menhaden, um, and those interests are competing for political decisions. So that's sort of what's going on with Osprey currently. I'd be happy to answer, whatever questions on Osprey and, try to answer some questions on the fisheries side if I can or feel like I should. Okay. Let's see.
I can read off the questions in the chat. We have two so far. The first question is, why aren't ospreys mentioned anywhere in the Virginia State Wildlife Action Plan or on the list of species of conservation in need? Are ospreys in the New River Valley area doing well or facing the same challenges?
Yes, I think that once so if we look at the tidal reach of the bay, so if we were to lose, so if the population, if nothing happens to turn menhaden around and the population declines, it will not decline within the lower salinity reaches. Okay, so those areas are not menhaden dependent, and they are self-sustaining. The same thing is true if you go beyond the fall line, into the western parts of Virginia. So those areas have been relatively recently colonized, and they are doing fine as far as I know. So I do not expect for those to be impacted. It's really the areas of the main stem that we're mostly concerned about. In terms of, why aren't osprey or are osprey in the list of species of conservation need for the state in the action plan? The answer is like this. So osprey, so that configuration of species of conservation need in the action plan, as you may know, is a relatively new construct, right? So there's been two versions of that. They only date back about 20 years. But if you go back earlier than that, osprey were a high priority for the state of Virginia, beginning in the 1960s and continuing until the early 1990s. So the Department of Wildlife Resources funded Mitchell Bird's work for over 20 years, working with osprey recovery. Once we get to the early 1990s, The state and in fact my research group turned away from Osprey feeling like we had successfully recovered them. And so it's Osprey are like a lot of species that we deal with, and that is that you work very hard, you put a lot of investment in them to recover them, and then you hope that they will sustain that recovery. Here's a case where you have to be vigilant and realize that they faced DDT in an earlier period, which was a significant impact on them. But then there are other things that may crop up down the road. And so we have to remain vigilant for a lot of these species. Different things can happen, and when they do, we need to address them. That's the situation with Osprey. They are not currently on the species of concern for the state in the action plan. I don't see a reason for them to. We could lose quite a bit of the bay population then and them still not be of high conservation concern, like many of the species that are currently on the list. I hope that answers your question.
Yeah, and just to let you know, we have around 15 questions in the chat. I
Okay.
can sit
We
through
can
some
move
real
quicker.
quick. The next question, two related questions were, how can we help? Are there any specific suggestions for most effective action to be taken by concerned citizens?
Yeah, I think that the biggest thing that people that are concerned about either the Chesapeake Bay ecosystem or Osprey as an indicator of the Chesapeake Bay. So be clear here. So we are using Osprey as an indicator because we can use them as an indicator for the broader Chesapeake Bay ecosystem and what is happening within that ecosystem. So it's not just about Osprey as a population of themselves, okay? It's about the broader ecosystem. What you can do is to express, your views. So menhaden and all these forage fish are a public resource. The public should have say over how that resource is used and allocated. So if you have a different opinion as to, how they're being managed and you feel like that more of that allocation should go to something else, please make your views known. That is that's the best we can do as citizens here.
Okay, great. Next question is, in the mid-Potomac River, ospreys seem to be doing okay. Can ospreys survive eating other fish when menhaden are not present?
Yes, so there are a bunch of other things that I didn't show you. Yes, and that was something that industry brings up quite a bit. Why don't osprey just eat something else? Well, they do. They eat a lot of different species, but there are differences. All those species aren't the same. The reason that menhaden are so important is they're what we refer to as a high lipid fish. So if you look at their energy density, it's over 200 kilocalories per gram. If you look at some of the other species, let's say croaker or spot, some of those, some of them less than 100 kilocalories per gram. And so that's the reason why menhaden are so important in the main stem. If you go to the lower salinity reaches, it happens that gizzard shad are a high lipid prey, okay? So yes, they can eat other fish. The question is, can they make a living on other fish? And so it matters what those fish are. And so it varies site to site depending on the available fish and which ones of those are really valuable fish.
Okay, great. Next question is, could ospreys do better if more fish were available from March to September, the full breeding raising time, or could they do better if more fish were only available after hatches occurred?
Yeah, the critical period for them is the sort of 6 weeks, May through mid-June or so. So they need to have uh, good resources during that period when the young are in a high growth phase. So that's the most important time. And unfortunately, some of you may know that menhaden are entering the bay later and later. And so that is a real concern in terms of, are they there at the right time for osprey? The last couple of years, they haven't been.
Okay. Next question is, how likely is that osprey from other healthy areas could migrate to our areas to fill in the population losses? Is that something you could detect?
With the work that we're doing right now, we could not detect immigration into the bay, but let me point out that the Chesapeake Bay historically has been the real producer. So I didn't mention, but during the 1970s, 1980s, and 1990s, we actually exported osprey out of the Chesapeake Bay to surrounding populations. So I took Osprey to Pennsylvania, West Virginia, Ohio, Indiana, Tennessee to help reestablish those populations. The reason was because productivity was so good in the Chesapeake Bay. So I think it's unlikely that the surrounding populations are now going to rescue the bay.
Awesome. Next question is, what would be the impact on the ecosystem if the osprey population disappears?
Yeah, that's always a good question. I think that I am not that concerned about the sort of disappearance of osprey and what that sort of trickle down would be on the ecosystem. I'm more concerned about what food stress in osprey has to do or what it suggests about the broader Chesapeake Bay ecosystem and how it is struggling. You know, there are dozens and dozens of consumers in addition to osprey that depend on these forage fish. And so I'm more concerned about the integrity of the broader ecosystem than I am, you know, a subpopulation of osprey.
Okay. And then there's a couple questions about menhaden, but just let me know if it's a little too outside the scope. One of them is, what is menhaden used for? I'm assuming more in like an industry sense.
Yeah, so there are two different industries that catch menhaden. One is the bait industry, so they are caught for bait. They're used for crab bait. They're used for lobster bait. So those types of things, they're sold as bait. That part of the industry is actually a tiny fraction. The larger fraction is what's referred to as the reduction industry, and that's the one that produced the two products that I mentioned from the beginning, and that is that they boil the lipids from the fish, so they take off the oil for omega-3 types of oil supplements, etc. And what's left over is the protein that's converted into fish meal. So those are the lucrative parts of the industry there. That's why they're sought. That's why there's so much of a lobby to keep the industry rolling.
Okay, great. Next question is, has there been discussion in other environmental concerns like global warming, extremely high temperatures during hatching and rearing seasons, salinity changes near shore, etc., that would affect the fish and then osprey populations?
Heat is a concern. And so the situation with osprey is that they return from South America in late February. They typically lay by mid-April or so. They hatch and raise their brood in May and early June. And so let's say that menhaden come in later, which has happened in the last 2 years. So we had a bunch of birds that did not lay in 2024, but then we had a spike. Once the menhaden started to come into the bay, which didn't happen until early June in 2024, we had a spike in laying, which is the latest we've ever seen. The problem is that virtually none of those were successful, and the reason is related to temperature. So osprey are squeezed. They're squeezed on the one side by prey availability, and they're squeezed on the other side by hot summer temperatures. It's hard for the broods, small broods in particular, to withstand the hotter temperatures. So they are somewhat squeezed. Yes, I believe that the water temperatures are affecting a change in menhaden. I believe that the center of abundance is shifting up the Atlantic coast. So the center of abundance, which used to be in the mid-Atlantic, is now migrated north into New England, and that is related to climate change. That's likely to continue. That's a concern because the Osprey, because the Chesapeake Bay historically has been such an important nursery area for menhaden. And if you go up the Atlantic coast, there is no replacement for the Chesapeake Bay, right? You don't have another estuary like that. The Chesapeake Bay is unique globally in terms of its structure. And so there are a lot of things going on here that are of concern when you look down the road very far.
Okay, great. And just a reminder to everyone, we're going to send some resources out on some political questions after this webinar, but for now, we're just focusing on Osprey questions. The next question is, would you be able to explain population dynamics? If food is available, Osprey populations increases until the available food crashes, and then Osprey population decreases until the food species recovers. Is this just natural population demographics or dynamics?
Yes. So I think what the person is indicating is that is there a density dependent effect, meaning that, the osprey population goes up, it crops down the food source, and then the population doesn't do so well, and then the prey recovers, and then we go through these cycles, right? That is not what's happening here. So years ago, I did some metabolic modeling of fish-eating bird species in the Chesapeake Bay for NOAA. And it turns out that even if you combine eagles, osprey, pelicans, great blue herons, which are the major fish eaters in the Chesapeake Bay, you come up to about 3% of if you combine all of their metabolic demand, you come up to about 3% of what the commercial take of menhaden is. The truth is that the bird predators in the bay do not have the metabolic capacity to crop down the fish populations like is being suggested. There is no density dependent effect like that going on between this predator prey dynamic here in the bay.
Great. Next question is, are you aware of other species struggling due to the decline in menhaden?
Yeah, we don't have as good data on them. I think some of you are probably familiar with striped bass and what was happening with them in the 1990s. So striped bass do depend on menhaden, and there's been a lot of controversy about reductions in the striped bass and health of striped bass and so forth. In terms of the birds, we do not. I'll mention that northern gannet. So northern gannet is a species. I showed a picture of them. They happen to stage in the Chesapeake Bay, and they're dependent on menhaden during the spring. So they breed in the North Atlantic, mostly on Newfoundland. About 30% of the North Atlantic gannet population stages in the Chesapeake Bay in the spring, depending on menhaden. I believe that those birds are primarily bypassing the bay now. So there are, I think, indications that other species are responding to what's happening, but we don't have the same type of evidence for those species as we do for osprey.
Great. Next question is, why did the sardine or Pacific sardine population crash? Was this due to climate change or overfishing?
Yeah, it in some of these cases they may not be either or. So the indication is likely that they were overfished. That doesn't mean that there aren't some components of abiotic things going on. We know that some of these forage fish, particularly in the northern latitudes, are very vulnerable to changes in temperature. And so changes in temperature can cause wide swings, great declines in some of these. So I'm not, tremendously informed about the details of the Pacific sardine.
Okay. Next question, kind of related to something you answered earlier, is besides overfishing, what other factors can be causing the osprey's decline?
Yeah, there are many factors that could. Uh, when we think about factors that are capable of driving large-scale population change, there are relatively few. Disease could, for example. We don't have any evidence of that. Contaminants could. Contaminants did during the DDT period. All of the contaminant sampling that's happened in recent years indicate that there is nothing currently that could be having the type of effects that we're seeing. It's possible that predation could. That's another general factor that we think about for population change. We have seen no indication of that. The public, many people on the industry side feel like that eagles are driving some of this. There is no evidence for that. As I indicated before, if there's eagle pressure on the osprey, it's lopsided toward the low salinity reaches where breeding density is 10 times higher. During 2024, we had 50 cameras out on nests, game cams. We collected over 1 million images. We did not have a single eagle on those images. So the truth is that we have systematically tried to go through these alternatives. And the only thing that really makes sense in terms of the preponderance of evidence that we see is that they're having food stress. And so we have watched birds dying in the nest. We believe that in 2024, we likely had over 5,000 chicks starve in the nest. So some of these other things certainly are having an influence, but we believe their influence is minor compared to the dominant influence of starvation.
Okay, great. I think that was the last question. So,
Okay, thank you. Appreciate your interest in this topic.
Thank you, Dr. Watts. Does anybody else have any questions? This has been a fabulous presentation. And again, we will be sending out additional information resources when we send out the recording, including how you can potentially get involved in the menhaden matter.
Okay.
Thanks, everyone. We so appreciate your taking part.